The overall goal of this procedure is to obtain quantitative information on the nanoscale interactions present between particles in a liquid-based colloidal system. This is accomplished by first preparing a functional colloidal probe by attaching a single particle onto a tipless atomic force microscope cantilever. The second step is to mount the probe onto the atomic force microscope and prepare a liquid cell with a colloidal particle substrate. Next, the spring constant and sensitivity of the colloidal probe are calibrated thermally using the microscope software. The final step is to use the colloidal probe and measure interactions with the colloidal particle substrate in liquid. For calibration, a direct measurement of probe sensitivity using a mica substrate in liquid is also made. Ultimately, colloidal probe microscopy can be used to measure the interparticle forces that may be responsible for coagulation kinetics and physical instability of the studied liquid colloidal system.
This method can help determine and measure key parameters responsible for the physical stability and coagulation kinetics of various liquid colloidal systems, such as those present in pressurized metered-dose inhalers, pharmaceutical intravenous formulations, biological systems, and several other systems.
Through the very precise measurements of attraction, cohesion, and decohesion forces of two solid materials, this method can provide a very deep insight into nanoscale chemical and physical interactions of these two solids. This knowledge can be used to predict the stability of pharmaceutical formulations, but also can be applied to